today we are going to learn about one of the most basic and important algorithms in data mining, and it comes under classification, that is K nearest neighbors algorithm. Which is actually also called as KNN in short form. So first of all, important point is that we should keep noting the main points, because most of the data mining concepts involve mathematical calculations, and if we understand the math behind the algorithms, then implementing it becomes much easier. So before directly jumping into KNN, let us understand why we even learn classification. Classification is nothing but, for example, if I give an apple to you and ask whether that particular apple belongs to the fruit section or vegetable section. So we are classifying this particular thing into fruit section, right? And then some other things which belongs to vegetable section, it will go there, and this particular thing will go into fruit section only. That is what classifying basically is. So classification is used for predicting classes, for example predicting yes or no situations, or pass or fail situation, spam or not spam situations. So in these things, so classification helps us basically to assign a label to new or unseen data. So then what is KNN and why do we need it for learning classification? Think of it like KNN as an hello world program of any language, because it is the most fundamental and basic important thing to know when we are learning about the concept of classification. Let us understand KNN with a simple example. Suppose I have to make a decision. Suppose I have to make a decision on what I should pursue after my BCA. Okay, suppose I have to make a decision what I should do after my BCA. Should I pursue masters or should I go to the job? So I look at the closest people around me, or I seek advice from the nearest people around me and see what decisions they make for me. Based on the majority opinion of those nearby people, I take my final decision. So this is exactly how KNN works. That is why it is called as nearest neighbors algorithm. And the core idea behind it is, let us first take a data set and then understand from it. So here I have a normal data set. It is a real-time data set only, where I have taken four persons and I've taken their workout duration and health score and then the fitness level. Firstly, in KNN, we calculate the distance between a new data point and the existing data points. For example, I've said that step 1 is to calculate the distance, right? So the calculating distance between two data points, we will be using Euclidean's distance for doing this. So for example, if I take an x-axis and y-axis, so this is the x-axis and this is the y-axis, and I have 2 points here, A and B. Here 2 points A and B, and in between these 2 points is I need to find a distance between these 2 points in a straight line. So let's say it is D, and for doing that, how can I do this? So listen, in A's correspondings, we will be having the value of x1, and in B's correspondings, we will be having the value x2, and here also we'll be having the same thing like y1 and y2. Based on this, we can extract the Euclidean distance formula, saying that, and so the formula comes out as x2 minus x1, these two values, and plus y2 minus y1 of whole square, and then the root for this. So this is how the formula is extracted of Euclidean's distance. And also remember, one more important point is, so the KNN algorithm basically works on labeled data. As I said before, it works on labeled data because it is a supervised learning, right? So we give in the labeled data to get trained, and then we expect the outcomes for it. And let's move on for solving this particular data set with the calculation. So let us solve the KNN algorithm using this particular data set only, and I have some new data points also to predict. Like, they will be given this kind of information in the question itself, saying that the new workout duration is 165 minutes and the new health score is 7.0. Then what is the fitness level of it? We should predict what will be the fitness level using KNN algorithm. So how do we do this now? The step one is, as I said before, we should calculate the distance. So we should calculate the distance first. Here, how do we do that? We already have a new data set. So let's calculate the distance. So what is the first data point that I have here? The workout duration 160 and the health score this one. So here, and one more thing, we can take these data points as, this can be the x1 and this is x2, this can be y1 and this one y2, as given in the formula that we have these kind of values. So we are taking like that, and then let's first calculate the distance to first data point that we have, 8.0 and 160. So now is the time to actually solve the problem. They would have given a data set like this and then a k value, and also they'll specify which distance formula you should use to solve it. For example, here we are using the Euclidean's distance formula, and then the new person's workout duration and health score for prediction purpose. So before solving this problem, let us quickly understand what KNN actually does. So the KNN is a supervised learning. So it's a supervised learning technique, which means it works on the labeled data, that uses the entire existing data set to classify a new data point. That's how it works. And instead of building a separate model, KNN simply compares the new data point with all the available data and calculates the distance to find the nearest neighbors. So based on the majority class of the nearest neighbors, the algorithm decides which class the new data belongs to. For example, in short, the KNN classifies new data by looking at similar existing data points. When we try to solve it, whatever the similar data points we get according to this health score, so this person will belong to that category of fitness level. That is how it basically works. Now we will try to solve it step by step. So as I said before, the distance measure that we are using here is Euclidean's distance, and the formula we can derive it as, so this is going to be our formula, where x1 and y1 is new person. So for example, here if we see, this is x1 and this is going to be x2, this is y1, and while this is, and after this is going to be y1 and this is going to be our y2. So we will try to solve this problem step by step. So after writing the formula and then deriving which is x1 and x2, So for example, we get this one as x1 and y1. So we will write the formula and the deriving these things. This is the step 1, and in the step 2 what we'll do is we'll find the distance with a. So the distance with a, that is 160 and 8.0. So this is the distance. Now we'll try to calculate according to this formula. Minus 7.0 whole square, and we will get the answer as minus 5 whole square plus 1 square, which is further simplified into 25 plus 1, and which will give us 26 root, that is 5.09. So this is the answer that we got for the distance with a. So here how we are comparing is 160 is taken from here, and then 165 is taken from here, 8.0 is taken from here, and 7.0 is taken from here. So that's how it basically works. After simplifying it, we'll get this kind of an answer, and we should do the same thing in the step 3. We should do the same thing with the distance with b, that is 170 and 6.2. So this is the thing. Now we will put it in the formula and try to simplify just like we did here. So let's see, 170 minus 165 whole square plus 6.2 minus 7.0 whole square, and this will be further simplified into 0.8 whole square, and then 25 plus 0.64 equals to root 25.64, that will be 5.06. So that is the answer. Like we will do the same thing with distance with C and distance with D also. The same procedure we are going to follow. So these are the two distances that we got from C and D, and we will move on to the step 6, which is an important step. So here we'll write the person and then the distance that we got for each person, B, A, C and D. So for B we had got 15.00, and for D 15.04. So in the step 7 we will select k equals to 3 nearest neighbors. So we will now select k equals to 3 nearest neighbors, where B is average and A is fit, then C is average. So based on this we will make majority voting, where average has come twice and fit has come only once. So majority is average, and the final prediction is new person's fitness level is average. So since 2 out of 3 nearest neighbors belong to the average category, the predicted fitness level of the new person is average. So that is how the KNN actually works. So one more thing is they had given a question related to KNN in 2026 paper, where they had given class A and class B, and they have given data point 3 and 2. We should use K nearest neighbor algorithm and use Euclidean's distance. So K equals to 3. We will try to solve this sum also once as an example. Okay, so we will try to solve this one now. So let us try to solve this problem. It is also simple, just like we solved the previous problem. We will write the step 1, that is Euclidean distance formula. So here the distance formula is x2 minus x1 plus y2 minus y1 whole square. So where x1 and y1 are 3 and 2. Okay, these are going to be x2 and y2. So we'll solve it step by step. The step 2 is distance from class A points. So the distance from class A points. Here from we'll take 1 and 1, that is class A's first distance, where we're going to solve it like this: 1 minus 3 whole square plus 1 minus 2 square. So the 1 is x2, 3 is x1, and 1 is y2 and 2 is y1. So that's how. And then after simplifying this, we'll get minus 2 whole square plus minus 1 whole square. That will be further simplified into 4 plus 1, which is root 5. We'll get 2.23 as an answer. And secondly, from 2 and 1, so from class A's 2 and 1, we'll try to solve it. 2 minus 3 whole square plus 1 minus 2 whole square. So we are done with the second data point also. We'll go for the third one, that is from 2 and 2. So we will do the same with the distance from class B points also. The same procedure we are going to follow. For that, that is going to be the step 3 of our problem. That is distance from class B points. So from 4 and 3 we will get this: 4 minus 3 square yeah. So after getting the answers for all the all the three data points from class B also, we're going to arrange the distances in the step 4. Just like we had done in the previous problem. So the points are 2, 2, 1, 4, 3, 1, 1, 5, 4, 6 and 5, and the classes that they belong to are A, B and B. You can check out in the question that which classes that they are belonging, and then the distance that we've got one by one, we shall write it 1.00, 1.41, 1.41, 2.23, 2.82, 4.24. So after that, in the step 5, we are going to select k equals to 3 nearest neighbors. That is, nearest 3 are 2, 2, 2, 1, 4, 3. These are the nearest ones, and this belongs to class A. 2, 1 belongs to class A, 4, 3 belongs to class B, and here the majority voting has gone for class A, and the voting for B is very less. So the final answer is that the point 3, 2 it belongs to the class A. Since 2 of the 3 nearest neighbors belong to class A, the given data point 3, 2 is classified as class A using the KNN algorithm. So for the conclusion, in this video we saw how the k nearest neighbors algorithm works step by step using the Euclidean distance formula, and we calculated the distance between the new data point and the existing data points, selected the k nearest neighbors, and used majority voting to predict the final outcome. So this is how the whole KNN thing works, and this shows that the KNN is very simple and powerful classification algorithm, and that makes the decision based on the similarity kind of data points. In the next part, we will try to solve another problem using KNN and understand it even better.